Hi there, it's the 23rd today. I wanted to experiment with a dual language solution or optimization. Uh, I have a Java program where I want to retain the user interface in Java, but uh, alter the algorithms to be run in Rust instead with JNI or Java Native Integration, or I don't know. Yeah. Anyway, uh, I vibe coded right before this a simulation of galaxies, uh, Barnes hut simulation in 2 dimensions. It's a massive amount of bodies that inflict gravitational forces on each other. So on the left here, you see almost starting how it looks in the start. And if I start it here, you can see that it's a bit slow to simulate this. It's 50,000 bodies. We get a frame rate of 8 frames per second. And you can see it sort of looks as the forming of a galaxy. And there it starts to spiral. So what we were actually aiming to do is to bring out the algorithmic parts into Rust and retain this user interface, which isn't very big, but it could be interesting, at least for me that have a lot of old Java code with a lot of very special user interface code that is hard to translate in bulk to Java to Rust. So let's see. So there's my prompt. I asked it to start the simulation in Rust on demand when the Java user interface gets commands. You send or you dispatch it to Rust, and then Rust will do Java callbacks, method callbacks. And I think this is the bodies are different, so it's polymorphic if I understand the simulation correctly. Yep, we'll see. Meanwhile, we can watch this. Oh, you haven't seen my face. Let's restart. Okay, what does it say? As you can read, he has made a plan. First, he designed a contract to make it possible to call methods from one side to the other and back. And add a Java UI app that retains the swing canvas. Yeah. And then a Rust library that can be dynamically linked. And a script to start it all. It has actually sped up, I see. It's up to 12 frames per second now. almost 13. Okay, it's finishing up. I will kill the old one, and then I will start this new run demo. So we'll just stop it. Chance. I will kill the old one. And I'll wire up the new one. Just a moment. Here it is. And we'll press S to see if it will be faster. Not really. Disappointing. Maybe I didn't. Yeah, it's a release build. This is disappointing. So the graphics itself was most of the cost then. Hmm. Yeah, yeah. So it was a failed assumption. I will make a fast. Just see to that it is. Put it in background. Oh, it didn't batch transfers. Oh, that's really stupid. Uh, since it's a tick-based frame system, of course you shouldn't make 50,000 language barrier calls, but you should batch your operations and send them in one call. I'll ask him to optimize this. It's actually like when doing disk drivers or whatever in operating systems, you actually want to have several commands aggregated so you don't wait synchronously or for one to be handled before dispatching the next. Okay. Sorry, I should have, of course, done this before. Yeah. Let's see if this gets to be any better. Oh, there it is. Or no, it's basically, it's actually worse still. We got to have 12 FPS earlier and now we're just at 10. Hmm. 11. That's strange. I'm asking if Java is still allocating stuff, which I thought was the point of the biggest point of slowness. Oh, there's heavy per frame allocations. Oh, okay, it's soon time to test, I think, the last version. I think this time he designed the interaction between the two language domains. Uh, he modeled the communication as shared memory instead, I think, or leases, perhaps. This ought to help a lot. So we'll see. How will it go? Hmm, strange. I must confess that I probably mistook the speed problem with this simulation to be in the computation, but it actually seems that if I go to faster computation, it will be eaten up by the extra cost of actually communication. Well, I I might have gained a percent or something. It's about 13 more than 12 now. Well, now it's down to 12, but 13. Yeah. Anyway, what you did see here, though, was that it's actually possible to rather simply do calls between the different domains. We could actually look into it. I don't know how it has. Oh, made Rust engine. So this is the Rust code. There's some math, of course. And this is the part which is much, much faster to do in Rust than in Java. Force computing and all that. And here's the engine. Let's see if we can see where the calls get done. Yeah, here it is. Here it does call method callback obj on frame batch with a number of arguments. which has to be serialized or marshaled as Java parameters, of course. So on frame batch is the Java method that paints. So we can look for that. Okay. There's just the definition. Okay, here is what happens. It just assigns a number of variables, and then there's probably a thread that looks at this and paints it here. Yeah. Okay, that's all for today. Good night.